Welcome to episode 14. Let's now learn error handling using the keywords try and except. When your program runs into a problem, Python raises an exception, and the program can't stop unless you catch it. With try and except, you can respond gracefully, show a friendly message, and keep going. In this lesson, we will convert messy user input into safe values, handle common mistakes, and learn about else finally, and raising your own errors. By the end, you will be able to protect your scripts from common crashes and make your programs feel professional to users. An exception is a signal that something went wrong during execution, like dividing by zero, reading a file that does not exist, or converting letters to a number. You wrap risky code in a try block and then add except blocks for the specific problems you expect. Catching only what you need keeps bugs visible while still guiding the user with helpful messages. You can also handle several kinds of problems in one place by listing multiple exception types. Here is the most common pattern you will write. Ask for a value inside a loop, try the conversion, and if it fails, print a polite message and ask again. This keeps the program alive without dumping a scary error for the user. You will see the loop only exits when a valid value is returned, which makes the rest of your code simpler and safer. We also strip spaces so that accidental spaces do not cause a failure. The try block can also use two partners named else and finally. Else runs only when no exception happens in the try part, which is great for code that should run only after a successful step. Finally runs every time, even if an exception occurred, and is useful for cleanup like closing files. In this example, we try to open a file, we report a clear message if it is missing, we process it in the else block, and we always print a done message in finally. Sometimes the data itself is wrong, even if the type looks fine. You can raise your own exception to signal that a value is outside rules your program expects. Raising a value error or a type error makes the bug obvious and directs the caller to fix the input. Here we write small validator functions to keep business rules in one place. Each helper either returns a cleaned value or raises a clear message. Challenge time. Build a robust tip calculator that never crashes on bad input. First, keep asking for the bill amount until the user provides a valid number, then keep asking for the tip % until that number is valid and between 0 and 100. Compute the grand total and display it rounded to 2 decimals, along with a friendly breakdown of bill, tip, and total. Here is a slice of the code to help get you started. Comment down below if you were able to complete the challenge without checking the solution. Pause the video and code it yourself using try blocks, except blocks, and small helper functions. Here is one possible solution and a walkthrough of what happens. Sorry for the smaller text on the screen. I wanted to fit the entire code on one screen for you to compare with your solution. We define a helper named ask_float that loops until conversion succeeds, so it never returns none, and the rest of the code can trust the value. We then ask for the bill, ask for the tip % with a range check, convert the % into a ratio, compute the tip amount, and then compute the grand total. Finally, we print a friendly receipt with 2 decimal places. Let us recap the big ideas. Use try around risky code, add except blocks for specific problems, and keep your messages helpful and calm. Use else for steps that should run only after success, and use finally for cleanup that must always happen. Raise your own errors when inputs break your rules so that bugs are found early and handled in a single place. In the next lesson, we will look at lists and tuples and how to store multiple values and work with them efficiently. Don't forget to hit that subscribe button.